will do later. And now I will have to write something for 1 over r as well. And if I do write that, what about this is base? Base over a hypot, S over R. So S over R is cos theta. S over R is basically cos theta, and I can write that S is equal to R cos theta. So S equals R cos theta. And further, if I do write this thing, because what I need 1 over r square in this formula. So if I write the s over cos theta, then this is r. So cos theta over s will come out to be 1 over r, and I can write that 1 over r square is basically equal to cos square theta over this s square. Because I will square it as well, n will reciprocate, so 1 over r square is equal to this thing. So here I have this thing is equal to this, and now I do put the values here. So by putting the values here, let me start from here. Then B of R is equal to mu naught I over 4 pi in integral. So for dl for 1 over r square, I can write cos square theta over s square. This I will write for 1 over r square, and for dl cross r, I will write dl prime cos theta, and for dl prime, I will write s over cos square theta d theta, and for the other one, I will write cos of theta. So cos theta will come here with this. Now what about the limits of theta? Because this should cover the whole wire, because we are integrating on TL. So all length will be covered here, and to cover all this length, let's say we start from here, let's say it is here, then the angle 0, theta 1 here, it is 0 here, or if this line is here, then of course it will be here. So the angle theta if it start from theta 1 value, and then it will span the whole wire and it will reach theta 2. So from theta 1 this will start and it will reach theta 2. So our integral is having the limits from theta 1 to theta 2. Now there is some simplification here, like cos square theta is gone with cos square theta, the s here is gone with the square this one, so only one s remains, and we are left with 1 over s cos theta and d theta. So we are left with the 1 over s and cos theta d theta. So is the integration is on d theta. So we will move this s outside, mu naught over 4 pi s, it will come outside, s will come out, and we are left with cos theta and d theta. So integral from theta 1 to theta 2 and cos theta d theta. Now I can write this is the differential of sine theta. Like differential of sine theta is equal to cos theta d theta. So it means the result of this when you apply the integral will come out to be sine theta. And this will come out to be mu naught over mu naught I over 4 pi s, and this one will be, if I put sine theta and then the limit theta 1 to theta 2, sine of theta 2 minus sine of theta 1. So this will be the integral solution here, theta 1 and theta 2. Now, if this is a very long wire, like this side is extending to infinity and this side is extending to infinity. So, what will happen? The angle which will extend their theta 1, then it will start from date 1 means it will go to almost you can say parallel to the straight line, and then the other angle will go to the other end. So the angles are basically extending this way. When it will become parallel to this one, so it will become 90 angle here. And if it will be the theta 2 is extending, it will to extending, and when it touch the infinity, like it's almost become straight. So approximately this one on this side is minus pi by 2 and this one on this side is plus pi by 2. So it will be extending that much. So here if I write sine theta 2 pi by 2, so it will become 1 here, and minus sine theta 1, it minus pi by 2. So it will become sine pi by 2 is 1. So minus 1 from here, and this minus. Because I know that sine is an odd function. So sine minus theta is equal to minus sine theta. So 1 minus from here, that minus will make minus pi by 2, this one plus. So 1 plus 1 will make this 2, and 2, like when you put here the values, then it is 2, and this 2 is simplified with this 4 here. So we are having B of R is mu naught 2 pi over S. And here for S, we are having this distance from the source to the observation point. From the source to the observation point, we are having the distance is S. And if you remember, we were having this distance equal to R. This R here, this R. So that one I can write is B will be equal to B of R. So you can write this will be naught I over 2 pi S, and for S you can write R as well because it's the same thing here, V naught I, and it is a function of R. So if I look here, the magnetic field came out to vary is 1 over R, not is 1 over R square from the source. So this is one of the difference, that magnetic field is 1 over R. It is slightly less decreasing or not decreasing at a rate where 1 over R square is decreasing. And then from here we can calculate another scenario here, that if we are having two wires, let's say we are having one wire which is carrying current I1, and the other wire is also carrying current I2, then just like Q1 and Q2 charges, so we are having now current I1 and I2, and their separation is, let's say, equal to D. Now, this scenario is opposite as we have discussed earlier. Similar charges repel each other, opposite charges attract each other. And here, current going in the same direction in both wires will attract each other, while current going in opposite direction will repel each other. So you will have to take that thing in mind as well. So if we have for this one, the magnetic field, the the magnetic field of I1, which is going like this, will interact with the, if current going this way, then magnetic field is going this way around this one, and similarly the magnetic field of I2 will be interacting with the magnetic field of I1. So if I consider one magnetic field of one and the other inside the influence of this magnetic field, then I have the relation, and the relation is that the force between the two will be I times the current which we have. Like if I consider this I2 wire in the magnetic field of I1 wire, then this will be equal to I2 and dl cross B. This is the relation for the force between the two here, and I can write this one is force between the two wires is equal. I will write it in scalar form because the DL and B are perpendicular, exactly perpendicular to each other, so it will be sine of 90 and that is equal to 1. So I can write that the magnetic field of this is B1, the magnetic field of 1 will be mu naught I1 over 2 pi, and the distance at which I am measuring this field is d. So mu naught I1 over 2 pi d. So if will come out to be equal to I2 mu naught I1 I2 over 2 pi d, and the integral of dl here. So what the dl will give us, the dl as a whole will give the length, and then if I move this length here, then it is the force per unit length, and that force per unit length I can write is tilted F, a small f, and this is equal to mu naught I1 I2 over 2 pi d. And now this is quite resembling with the Coulomb's law. Like over there, epsilon naught, so here we have mu naught, q1, q2, and then 4 pi, here is 2 pi, and then over there is r square, and here we are having this thing equal to d because the magnetic field is varying is 1 over r, r1 over d, r1 over s. So with this example completes, and then we will move to example 5.6.